Now we know how to create variables, we can move on and use these variables in calculations within our program. We're going to have a look at some of this simple arithmetic covering addition, subtraction, division and multiplication within ABAP. So first of all, let's have a look at addition. It's all very simple stuff. First of all, we'll just tidy this up. Let's get rid of those constants. So let's say our program needs to add two numbers together. Each number is stored in its own unique variable, and we want to store the product of the two numbers in a brand new variable that we can call result. So first off, we'll declare a new data variable. And we'll actually use the like statement. And we'll make it the same as pack decimal 01. Let's line them up. Now, as you can probably imagine, it doesn't take much in the way of code to add two numbers together. All we need to do is write result, which is the variable we declared here, equals, because my typing's terrible, I'm just going to copy integer 01 plus packed decimal 01 with a full stop at the end. Pretty printer, everything looks good. We'll check it. I managed to get the syntax correct. So let's take a look at what this is actually doing. Very, very straightforward. It's just adding integer 01 and packed decimal 01 and putting the product of those two into the variable result. If we want to check, then let's add a write statement. And we'll just write result. Activate our program. And there we can see the result, 16.5. Let's go through this a little bit deeper. Even though it looks super simple, there's just a few things that we need to go through. And the first one is, for any arithmetic operations, we always have to have the equal sign to the left of the actual calculation. And the variable to hold the result needs to be to the left of the equal sign. When the calculation is executed, the two variables to the right of the equal sign always stay the same, and it's only the variable to the left that will be updated. Now in our case, we have a variable called result. If that already held a number prior to the calculation taking place, it would then be overwritten with the new result of the calculation. You'll also notice I put a space in front and behind the equal sign. You've always got to do this. And also between the actual arithmetic operators as well. Always put a space in front and behind. As your calculations become more complex, you'll start to use parentheses, and you must ensure that you insert blank characters before and after the parentheses to separate them from your arithmetic operators. Now, when I say you've got to make sure you insert a space before and after, one space is the minimum. You can, for instance, like I often do, so I can line up my code and make it a lot more readable, you can insert as many spaces as you want, and it will all still work the same. And this allows us to define our calculations across many lines within the ABAP editor. Now, as you can imagine, we're not just stuck to calculating the value of variables. We can also use individual values in our calculation, just as shown here. So as an example, let's just output the result. Let's now have a very quick look at subtraction. So I'll just copy the previous example. So all I'm doing is changing the plus to a minus, and then it'll take away the minus 5.5 from 22. So I guess in my eyes, that's going to add it to it. There we go. So 22 minus 5.5 is 27.5. I'll tell you what I'm going to do right now is take away this minus sign so it's a bit easier to understand. Well, for my old brain anyway. So do a quick test. 22 minus 5.5 is then 16.5. The next one, let's have a look at division. Simple slash, which is the division sign. See the result, and we get a 4. You know what? That was by pure chance. I didn't expect it to be a whole number, but yes, 5.5 multiplied by 4 is 22. If we did have a decimal within the result, it would have been shown. And the last one we'll try, oops. As you can guess, is multiplication. And there we go. All very simple. Now, just before we move on to the topic of conversion rules, I'll just add in that when we talk about arithmetic, you also have the option of using some other statements called add, subtract, divide, and multiply. Now, the syntax for these is a little bit different because the way it works, let's make that into a comment, is we can say add 8 to result. And then 8 would contain, let's have a look in this case, 22 plus, that's 27.5 plus 8 would be 35.5. Let's do a syntax check. I haven't used this in years actually. Hope I got, yep, I got it right. Let's just test it out. Here we go. So we can see the result is 35.5. So it's adding the value of 8 to result. But I've got to say, you hardly ever see this used in programs. And why would you want to use it when you can use really simple calculations just like this? As we've been creating this program, you'll have no doubt seen we're using various different data types when declaring our variables. Now, it's a programmer's responsibility to make sure the data types you use are compatible with each other when you use them for calculations or moving data to and from those objects throughout your program. You do not want to be performing any calculations on variables and numbers that do not match. For example, a variable defined as an integer cannot be multiplied by a character. The two data types are incompatible, and as a result, the system would generate syntax errors and a runtime error if you try to execute the program. Now, SAP have built in some automatic data type conversions from many of the standard data types that are available within ABAP. There are scenarios where the inbuilt ABAP conversion rules are not appropriate, and it is important you become familiar with the inbuilt conversion rules and know when to manipulate the data prior to using them in your calculations. So let's take a look at the conversion rules that currently exist. We won't go through every one, but you'll get a good flavour of what the conversion rules are and how you can use them throughout your programs. Now, conversion rules are predefined logic that determine how the contents of the source field can be entered into a target field. If you add an integer field containing the value of 1 and try to insert that value into a character string, the built-in conversion rules will determine exactly how this should be done without throwing any syntax errors or runtime errors. Let's have a look at some examples. So let's suppose we add a variable called num1 of type packed decimal, and we add a result. Oops, help if I could code properly. We add a result of type integer. If we add a calculation where a packed decimal number was moved into an integer field, the inbuilt conversion rules would round the decimal places of num1 up or down and insert the contents into the result1 field. Blimey, you can see I wasn't paying attention there. 1 second, there we go. So let's fill this out a little bit more. So let's say we had a value of 3.33. Okay, so what we will get here is result 1 would result in a value of 3. Probably best if we output this to our screen. Let's see what we come out with. There we go, we end up with a value of 3. And that's because the inbuilt conversion rules rounded the number down. If we had a value of 5.55, then this time result will contain the value 6 because the rounding would go up. So you can see automatic conversion rules are being applied. As you work with different data types within your program, many different conversion rules will be applied automatically. And as I stated before, it's up to you as the programmer to understand these conversion rules, understand the data types you are using within your program to ensure no runtime errors will occur. Now I want to step back just a little bit and discuss the division operator. Earlier we saw the format of a simple division calculation. Now I'm sure you remember back to your old school days that when you started to learn how to divide one number by another number, you were first taught about the remainder values. In ABAP, we have 3 different ways we can divide numbers together, and this allows us to concentrate on the remainder, the actual integer division, and the standard division result with decimal places. So let's just go through these 3 so that you'll become familiar with them when you need to use them in your own program. So back in the code, let's add another little separator. And we'll generate some division calculations. Haven't used the result 2 before, I don't think, no. So here's the first calculation. I'll just generate the outputs. Okay. Tell you what I'll do as well. Let's just line these up so they're a little easier to read. Oops. So we defined 3 variables, num1, num2 and result2. Num1 has 2 decimal places with a value of 5.45. Num2 has 2 decimal places with a value of 1.48. And result2, which will be the product of our calculation, just has 2 decimal places with no value defined. And I made a little error there. There we go. So our result will be num1 divided by num2. Ooh, I've got an error somewhere. Let's have a quick look. Value expected, not values. Oops. Looks like I went all plural on it. There we go. It's useful how the syntax checker does actually identify what the errors are sometimes. You can see it's looking for value instead of values. Oh, looks like I've already used num1 in the program. Where have I used num1? Oh, there it is, look. Used it up there. Let's change it. We'll use num-A and num-B. Okay, everything looks good. I'll activate the program. And when we execute it, we can see a value of 0. Oh, silly me. Look at that, I'm outputting the wrong result. Result 2, that's what we want. There we go. So the result is 3.68. So that's a standard division. Nothing too spectacular there. Now we'll have a look at the integer division. So we'll use the same values. Now obviously I've renamed actual variable names. Now for the integer division, instead of using the normal divide symbol, we actually use div. So what's integer division? Well, as a reminder, what it will do, it will divide one number by the other, but the result we get is just going to be the integer value. So this means we will not get the decimal places. Let's activate our program, and of course I've got syntax errors. Oh, silly me. Copy and paste it all wrong. There we go. Now we'll execute the program. Oh, I've done it again, haven't I? Outputting the wrong result. Here we go. Oops. Now when we execute, we can see we're getting a result of 3. We're just getting the integer, the full number, not the decimal places. So now, as you can probably guess, the last example we want to look at is the remainder. I'm going to make sure I get no syntax errors this time. Promise. Okay. Now with the remainder division type, we want to use MOD. So the result we get here is going to be the large number divided by the small, but we will only be shown the remainder value of what cannot be divided directly into num-e. I'm sure you know what I mean. I might make it sound more complicated than it is. Let's execute the program and see. Ooh, one thing. Look at that, I nearly had that syntax error. So just change that. We'll try our program. Here we go. So now we've got a remainder of 1.01, which hopefully, by my calculation, should be correct. Let's bring in the calculator. 5.45 divided by 1.48, 3.6824. That means 3 times 1.48 gives us a value of 4.4. So if we take 4.4 from the 5.45, that gives us 1.01, which is the result we've got there.